Hi, let's see one of the gate question which was asked in the year 2003. Here they have given one function called f which is taking a node as input parameter, right? This node structure they have defined already, right? Meaning that item is one kind of a node where it contains data and a next pointer which can able to hold another structure, right? So here this particular P is a pointer which can hold another structure, okay. So here they are simply saying that they are trying to return certain value. So they have given in a single line, right? P double equal to null, or P tends to next double equal to null, or P tends to data less than or equal to P tends to next tends to data, and f of, so this is a recursive function, f of P tends to next, mean that in single line they have concluded everything, right? And they are asking that for a given linked list P, the function f returns 1. Function f returns 1 if and only if so there exists a bijective condition, right? The list is empty or has exactly one element. So meaning that when this function is going to return the value 1, guys, right? So here they are using some kind of R operator, right? So when you are using R operator, right, if at least one condition is satisfied, then obviously you are going to get the return value as 1. So obviously when this condition is true, it is going to return 1, right? So assume that there is no data, meaning that it contains null. Then obviously is P double equal null or not? Yes. Then it will simply return 1, right? Obviously it is a chance, right? Or if we have one data, let me take if we have one data like number 1, and here it is null, right? If P tends to next equal to null, that condition also says if P tends to next double equal to null, or if P double equal to null, right? If there is no data, or if there is only one node, then also this function is going to return the value 1. Or or the another case is they have given certain kind of condition. But if you observe, the list is empty or has exactly only one element. So obviously our discussion is valid for this option A, right? What about the other option? Just check. The elements in the list are sorted in non-decreasing order of data value, right? So meaning that the third option is they are trying to check for ascending order, that is what non-decreasing order, right? So P tends to data, I mean, is 5 less than or equal to 6 less than or equal to 7, meaning that when you are traversing node by node, 5 less than or equal to 6 less than or equal to 7, and so on, they are going to traverse, right? If it is going to satisfy, then it is going to go for again a recursive function call, meaning that once this condition is satisfied, it is going to go for again next one, and it is going to check for these two, and so on. It is going to happen, right? So at one point of time, if this condition is fail, obviously it is going to return 0 or not, return 0. Why? Because is P double equal to null? No. Is P next tends to next double equal to null? No. But when obviously this condition fail, obviously all are fail, your result is going to be 0. Result is going to be 0 or not? Yes, right? Then what it is expecting, so it has to have compulsory in non-decreasing order of the values, right? So this option is also possible, okay. The elements in the list are sorted in non-increasing order, so we are expecting in increasing order. Not all elements in the list have the same data value, no, right? So they are saying that all elements should not have the same, yeah. So no, they are expecting in the shorted order, so this option is also invalid. So here option A and option B are true, right? But the point is here, out of these two you have to select the best one, Let's select the best one, right? So here I will choose the option B as the best one, because option B includes option A, right? So it may have empty data, or it may have one node, or it may have many nodes. But if you select the option A, it may not include many nodes. That's why option B is the correct answer. Okay, I hope I understood clearly. Thank you.